Hello, I'm Pushkar and I'm a master teacher in chemistry at Vedantu and I'm discussing JEE Advanced 2019 Chemistry Advanced paper. This is question number 18 which belongs to the chapter liquid solution. So let's see what is this problem and how to solve it efficiently. So the problem is on dissolving 0.5 gram of a non-volatile non-ionic solute to 39 grams of benzene. Its vapor pressure decreases from 650 mm of Hg to 640 mm of Hg. So this initial line tells us that this is lowering in vapor pressure when a non-volatile solute is added to the volatile solvent. Now the depression in freezing point of the benzene upon addition of the solute is. So they are giving the information of relative lowering of vapor pressure and they're asking what? Delta TF. So this is going to relate two subtopics into one single problem. And these two subtopics which are there are the relative lowering of vapor pressure and the depression in freezing point. So let's start solving this problem. So we know that P naught, which is vapor pressure of pure solvent minus PS vapor pressure of solution divided by P naught is equal to NB divided by Na plus Nb, where Nb is equals to mole of solute and Na is equals to mole of solvent. Let us assume A and B stands for this. So if we rearrange this equation like this, that 1 minus Ps upon P naught is equals to Nb upon Na plus Nb, and then that means Ps upon P naught is equals to 1 minus Nb upon Na plus Nb, and which gives us Na divided by Na plus Nb. And let's call this equation number 2. Let's call this the familiar one as the equation number 1. And let's do 1 upon 2. Divide 2 from 1. If we do this, we are going to get this equation P naught minus Ps divided by P naught, Ps is equal to Nb upon Na. And it is advisable to take this form. Why? Because when you see that the pressure is decreasing from 650 to 640, that's a considerable change. And that means that solute concentration is very large. And that means Nb plus Na could not be approximated to Na, which is the usual course in solving this problem. तो आप Nb plus Na को आप नहीं लिख सकते कि that is equal to Nb, or that is equal to Na. So in these situations, what to do? To take this approach. That is a better approach. Here we have not taken any approximation and we get a very neat and clean equation P naught minus Ps upon Ps is equals to Nb upon Na. Now this equation can further be simplified. Let's see how. This Nb upon Na can be written as Nb upon Na into Ma divided by 1000, where Ma is the molecular mass of solvent, and let's multiply here also by Ma upon 1000. So effectively nothing had happened, but this quantity becomes what? Molality. So if I write it here, then we can say that P naught minus Ps upon Ps is become equal to small m into Ma, where Ma is the solvent's molecular mass divided by 1000, and here solvent is benzene and the molecular mass is 78. So we got the value of M. Straight away by this equation we got the value of M, which is equals to 650 minus 640 divided by 640 into 1000 and divided by 78, and which gives us small m is equals to 10 upon 64 into 1000 upon 78. That's molarity in mole per kg, kg per mole per degree centigrade. Oh, sorry, moles per kg. So at this point we got the molality. Now in one single step we can say final part of this problem is delta TF is equals to KF times M. And Kf is equals to 5.12. So this is 5.12 into 1 upon 64 into 1000 upon 78. And upon solving this, you are going to get this number, which is shown here. It is 5.12 into 0.05 into 1000, same. Now in this slide, the problem is solved by a very different perspective. Okay, in this slide, first we have calculated the value of M solute and then we have solved the problem. So you can see the solution. You can see the solution here, which is given here, provided with this solution, and you have alternative solution. So you have noticed that the 0.5 gram of a non-volatile solute, which is added to the 39 gram of benzene, this information is not needed at all. To solve this problem, we just need this information that the vapor pressure decreased from 650 mm of Hg to 640 mm of Hg, and what is the molecular mass of benzene, and what is the molecular, and what is the Kf of the benzene. So I hope that you understand this solution which I have given you, and especially this equation where P naught minus Ps upon Pb, Ps is given as Nb upon Na, and it has been converted into molality. See this very interesting equation, and from this you can solve the problem. I hope that you understand this problem and enjoyed this problem. Thanks very much for watching.